Hello students, welcome to Modern Book of Education, Kolkata. So this is the continuation part of the oscillation chapter. So if you do not watch the video, please go and watch the video. I have I have teach this part, total energy, potential energy, the equation of all these parts. So please go and watch all the concepts and come here. Okay. So in today's video, we will learn that the graph of total energy, potential energy, and kinetic energy, and all other concepts related to SHM. Okay, so starting the video now. So all the if I write all the equations, that is one is y equal to a sine omega t. This is the displacement equation. Another is v equal to a cos a omega cos omega t, or it is plus minus omega into root over a square minus y square. Okay, now third, acceleration is equal to acceleration is equal to minus omega square x or y. Okay, and fourth is equal to total kinetic energy. Kinetic energy is equal to half m omega square y square a square minus y square, sorry, half m omega square a square minus y square. Okay, fifth, kinetic energy, potential energy is equal to half m omega square y square, and the value of total energy is half m omega square a square. So this is the constant value. Total energy is always constant. Okay, so till now we have completed the topic. Now coming to the next topic, that is the graph of total energy, potential energy, and kinetic energy. But before drawing the graph, I want to start a concept that you have to remember in a timeline or in a number line, that is in a line. Say this is the mean point, this is the mean position of the SHM or the oscillation. Okay, now so this is the plus amplitude, y equal to plus amplitude here, and y is equal to minus amplitude here. Okay, and here y equal to 0. That means this is the mean position. Clear? Now in the 3 points I have to write down all the terms that we have understood in the previous video, so that it will make a concept of the all the terms. It will make you clear that all the terms in where the all the maximum values and where the minimum values are there. Okay, so if restoring acceleration, sorry, velocity, acceleration, kinetic energy, potential energy, total energy. Okay, I am writing all these topics in each point, in these 3 points. If restoring V A K P T. Here, if restoring potential, velocity, acceleration, K P T. Clear? See, in restoring, I have told you that the restoring force, the work of restoring force is to keep the particle to its mean position. Okay, so if the restoring force at the mean position, means where the net force acting on the particle is 0. So restoring force is also 0, and the work of restoring force is to keep the body in the mean position. So restoring force here is 0, and it is proportional to negative of displacement. That means here is the maximum value. Restoring force is maximum here. Okay, more the body goes from the more the body creates a displacement from the mean position, more is the restoring force. Clear? So with the restoring force, if there is a force, then there is a acceleration. So acceleration is also maximum. Here is 0 and here is maximum. Now velocity. At the mean position, velocity is maximum, and the extreme position velocity is 0, because if the velocity is not 0 in the extreme position, then the body will not repeat its path. The body will continues to move. Okay. If the velocity of the body at the extreme point is not 0, then the body will continue its movement. So if the body's velocity is 0, then it will return to its position. So velocity here is 0, in the extreme position velocity is 0, and the mean position velocity is maximum. Okay. Now coming to kinetic energy. Kinetic energy is related to potential energy. Kinetic energy is related to velocity. So half mv square, that means if velocity is maximum, kinetic energy is also maximum. Here is kinetic energy is minimum. Okay, here is minimum. Clear? If kinetic energy is maximum, then potential energy should be minimum to maintain the total energy constant, and it is constant. So here is it is kinetic energy maximum, so potential energy is minimum. Sorry, minimum to maximum. Total energy is constant. See here. Okay, the total energy is constant, and it is here potential kinetic energy is minimum, so potential energy will be maximum, and total energy is constant. So at all the points you have now understood all the points, that all the topics, all the terms, which one is maximum, which one is minimum. Clear? So try to remember this, because the work of restoring force is to maintain the mean position, the body's mean position. So restoring force at the mean position equal to 0, and in the extreme position is these are the maximum. So if restoring force is 0, then the acceleration will be 0 in mean position, and the extreme position it will be maximum. Okay, the velocity at extreme point will be 0, because the particle have to return to its mean position due to restoring force. So the velocity will be 0 in the extreme position, and it is maximum in the mean position. So if velocity is maximum in the mean position, then kinetic energy is also maximum, because half mv square. Okay, if kinetic energy is maximum, then potential energy is minimum, and total energy is always constant. Now I have to draw the graph of kinetic energy, potential energy, total energy. Clear? So these are the axes where energy versus displacement is drawn. Energy versus displacement. So the graphs will be like, and the total energy is like, sorry, okay. So this is the graph of energies with respect to y, but you have to know which one is the total energy, which one is the potential energy, which one is the total energy graph. So from the previous diagram, you have come to a conclusion that the kinetic energy is maximum at mean position. That means it is the diagram of kinetic energy, and kinetic energy is minimum at the extreme position. Okay. Now potential energy is minimum at the mean position. So this is the potential energy graph, and the total energy is constant. That means this is total energy. Okay. So this is the graph of total energy, potential energy, kinetic energy. It is very important for your board and NEET joint purpose. Okay, clear? So you have understood the graph. Now this topic is completed, and we will draw some numerical. We will done some numerical in the later video. But let's complete another theoretical part of this chapter, that is time period. Okay, here different cases will come and different time value of time period will be there. Number one, first of all, the time period of simple pendulum. First of all, the time period of simple pendulum. Okay, so what is simple pendulum? It is just like a pendulum. It is a pendulum with a massless string and a bob. The bob is not massless, but the string is massless. Now, if there is an experiment that time you have to find the time period of simple pendulum, but you have to displace the pendulum with a angle of 4 degree only. 4 degree only. This is a very small angle, so students, most of the cases students do not follow the 4 degree angle, and they will displace more. Okay, 10 degree, 15 degree, 20 degree uh, to complete that finding the value of time period. Okay, but you have to displace the bob with 4 degree angle only. Clear? Okay, so this is the simple pendulum. So in simple pendulum, the time period will be time period formula. The formula of time period will be 2 pi root over L by G. It is L by G. L is the length of the pendulum. L is the length of the string, you can say, or G, and G is the gravitational acceleration, G effective. It is actually G effective, the value of formula G effective, because there is a question in a like that the in a lift a pendulum is there and the lift is falling with acceleration A, and another case in a lift the pendulum is there, the lift is going up with acceleration A. Then what is the time period of the pendulum? In this case we know that the effective acceleration is G minus A, and in this case the effective acceleration is G plus A. Okay, how this effective acceleration G plus and G minus A works, you have to watch our the NLM video. Okay, so you have to go to the Modern Global Education channel and go to the playlist and see the video of NLM. Clear? Okay, the total time period will be then 2 pi root over L by here G minus A, and here the total time period will be 2 pi root over L by G plus A. Clear? Okay, so it is the time period of simple pendulum is 2 pi root over L by G effective, that is G plus A and G minus A. Clear? Now the second time period, it is the time period in a tunnel of earth. If we excavate a tunnel just like that in our earth and drop a body from this, and this is the center of gravity of earth, center of mass of earth, then the time period of the body is 2 pi root over R by G, where R is the radius of earth. Okay, 2 pi root over R by G. If we excavate a tunnel and the time period of a body will be 2 pi root over R by G, where R is the radius of gravity, radius of curvature of our earth. If we put the value here 2 pi root over R, that means 6400 kilometer. So kilometer to meter 10 to the power 3, and G value of G is 10, say, then it will be 2 pi will into 6400, that means 640 into 10 to the power 4 by 10, that means 64, that means 2 pi into 10 to the power square into 8, that means 16 pi into 10 square, 16 pi into 10 square, that means 100. So 16 into 3.14 into 100, that means 16 into 314. So this will be in second, so it will be this will be in second, and you have to change the value, you have to transform the value in minute, then it will be 80, just like 83 minute. That means if we drop a body and it will complete a oscillation, full oscillation. The time period of full oscillation will be 83 minutes. That means the body starts from here and move here and return to here in 83 minutes. That means the total path, total time period will be 83 minutes. So halfway is 83 by 2 minutes. So it is a very short time to travel a body on the full distance apart, but it will not possible because in the center there is lot of things, lot of magma and etc. So we cannot excavate a tunnel, but you have to know the time period value 2 pi root over r by g, and the value of this will be nearly equal to 83 minutes. Clear? Okay. Now third point. Third is time period of a floating body in a liquid. Okay, time period of a floating body in a liquid. Say in a liquid container, there is a cylinder which is floating on the liquid. Okay, which floats on the liquid. So if we press slightly, then it will oscillate in this manner because of the upthrust provided by the liquid. The value of upthrust will be V rho g. We will discuss this formula in the fluid chapter, but you have to know this. The value of the upthrust will be V rho g, where rho is the density of the liquid and sigma is the density of solid. So time period, the value of time period will be 2 pi root over, if the length of this cylinder is L, then it will be 2 pi root over L by G into sigma by rho. Extra term sigma by rho comes here. It will 2 pi root over L by G into sigma by rho, where sigma is the density of the solid and rho is the density of liquid. Okay, sigma is the density of solid and rho is the density of liquid. The derivation of this topic, we can derive the topic, but the formula is much important, so you have to know the formula for NEET JEE main purpose. So 2 pi root over sigma into sigma, that is 2 pi root over L by G is the main formula, and there is sigma by epsilon, sigma by rho. Okay, so time period of a floating body is 2 pi root over sigma by rho into L by G. You have to know the value. Clear? This is the time period. Okay, now these are the three time period, value of time period. You have to remember the number one is time period of a simple pendulum, the second one is time period of a tunnel of earth, and the third one is time period of a floating body in a liquid. Okay, and now the next important time period is time period of a spring. Okay, this formula is very, very important. If a spring hangs like this and if we attach a body with the spring of mass m or extra something, so if we now displace the particle towards down and remove the force, then the body will oscillate, the spring will oscillate like this. Okay, so this is the time period of simple pendulum will be 2 pi root over m by k. The derivation is not important for NEET and JEE purpose. If we have to know the derivation, then please comment below. We will make a separate video of the derivation part, so the student of both students will get help. Okay, so 2 pi root over m by k, where k is known as the spring constant and m is the mass of the spring. Excuse me, mass of the spring. Clear? Now this is the time period 2 pi root over m by k. You have to remember this is much important. And now a concept comes, the effective k. Here the concept of series and parallel connection comes. Say here I am drawing two combinations. One is like this. Here is a block, okay, and like this. Here is also a block. So if the spring constants are k1 and k2, and here the spring constants are k1 and k2, this structure, this connection is known as series connection. Why? This is known as series connection and this connection is known as parallel connection. Why? Because if we displace this particle like this, if we displace the particle in this direction, then k2 and k1, the total force on this body will not divided in the two in equal halves, will not divided in the two springs in equal halves, because if the k1 and k2, if k1 is greater than k2, say if k1 is greater than k2, then k is f is equal to ks. If the force is same, that means f is equal to kx, that means k is inversely proportional to x. That means the which one has the maximum k1 k. So if if a spring has k is greater than another spring, then it will deflect less, and if a spring has more k, more spring constant, then it will displace less, and if a spring has less spring constant, it will displace more. Okay, so spring constant is inversely proportional to displacement. Clear? So the total force will not get divided by two halves. So this is a series connection, and the total in a series connection in a of a resistor, we can say that the current is same. Okay, so here is the total force is same, k1 and k2. In k1 the force is same and in k2 the force is same, but it will not get same deflection, same displacement, because of the change in values of k1 and k2. So in series connection, this is the series connection, but this is the parallel connection where both the starting points are connected in same position and both the ending position of k, that means spring, is in the same point. So and also if we displace the body with some force, then it will get divided, but the force will get divided into two equal halves, because it is a parallel connection. In resistance parallel connection, the potential, the current, actually potential will be same, but the current will get distributed in equal halves. So in parallel connection, the force gets distributed in equal halves. So this is the parallel connection and this is the series connection. Okay, clear? Here starting, ending, starting, ending, that means the series connection. Here all the starting points are same and all the ending points are same. So it is called parallel connection. But you have to remember this concept that if the displacement force, if we displace the body with some force, then the force will be divided in force will be equal, force will be equal for this both the spring, but in this case the force will be get divided in equal half, f by 2 f by 2. Okay, so this is the series connection, this is the parallel connection. Now the formula of series connection will be of just reverse of the resistance series connection. That is the parallel formula of series connection. In the parallel formula of resistance connection will be in the series connection of spring, that is 1 by K equivalent equal to 1 by K1 plus 1 by K2. Okay, and for this K equivalent will be K1 plus K2. There is also derivation of this topic, but I have to make the video short, because the short video will clear your concept and you can memorize from this easily, very easily. So K equivalent K1 plus K2. If you do require some derivation part, then please comment below. I will make a separate video about this. Okay, so 1 by K equivalent equal to 1 by K1 plus 1 by K2. This is the series connection formula, and this is the parallel connection formula, K1 plus K2. So now the time period will be for series connection. I am erasing this part. So time period for series connection will be T equal to 2 pi root over m by K, but here K is equal to K1 K2 by K1 plus K2. Okay, and time period for this case parallel connection is 2 pi root over m by K equivalent, where K1 plus K2 will be. Clear? So these are the time period values. Okay, and the series parallel connection. Clear? You have understood all the topic? Okay, so these are the values of time periods. These are the values of time periods. The four value of time periods you have to remember. First one is this value of simple pendulum, 2 pi root over L by G effective and G minus A, G plus A. Now the time period turning about 2 pi root over R by G. Time period falling floating body in a liquid, 2 pi root over L by G into sigma by rho. And the next thing is 2 pi root over M by K, where series and parallel connection are shown here. Clear? So this is the topic of time period, and now let's coming to the last topic of this chapter, that is free forced and damped oscillation. Okay, now so free forced and damped oscillation. Let's see, free oscillation, that means a body is oscillating with its own frequency, that means every body has its own frequency. So if a body is oscillating with its own frequency, then it is known as free oscillation. The value of frequency, we know the time period 2 pi root over m by k. So frequency will be, time period is 2 pi root over m by k. So frequency is 1 by time period. That means frequency will be 1 by 2 pi root over k by m. Okay, so this is the value of frequency of free oscillation, which is its own frequency. Okay, now the if we draw the oscillation graph with amplitude, with respect to amplitude, then the graph will be like that. I am drawing these lines because here there is no damping forces, that means the amplitude will remain constant, and I am erasing this part. The amplitude will touch down this line. Okay, so this is the amplitude versus displacement diagram. The maximum value of amplitude is same at every point. Okay, so this is the, here is the amplitude, the direction of this amplitude, and it is the displacement. Okay, so this is the free oscillation diagram, free body oscillation diagram. Clear? When a body oscillates with its own frequency. So this type of frequency, this type of oscillation is not possible, because in actual nature there is always a damping force. Okay, so now coming to the forced oscillation. But before coming to the forced oscillation, now coming to the damping oscillation first, damped oscillation. Damped means this is the real oscillation, because here are some here are some damping or damping forces are present. Damping forces are present, just like friction. Friction is a damping force. Okay, it will damp the oscillation, the frequency of the motion. So damping forces are just like friction. So the damping forces, the diagram of damping forces, damping oscillation is, it is just like that. Okay, this is the actual oscillation, damping oscillation. Clear? Now here is some extra topic of the equation of damping oscillation of the differential equation, which is x is equal to, or y equal to, actually we can say y is equal to a into e to the power minus bt by 2m cos omega t plus phi. Y equal to a into e to the power minus bt by 2m into cos omega t plus phi. I am clearly writing this equation. Y is equal to, this is the differential equation of this of this oscillation, a into e to the power minus bt by 2m into cos omega t plus phi. This is the differential equation of damping oscillation, where b is the damping constant. B is known as damping constant. You have to remember this equation, because most of the time equation comes like this, and they have to they told you to find the value of b, or the find the value of a, or the find the value of omega. So you have to just remember this equation, nothing you have to understand of this equation, you have to remember this equation only. Okay, this is a damp oscillation. Now the forced oscillation, this is the important topic, forced oscillation. Forced oscillation means oscillation which is done by external force. Okay, an external force is doing oscillation. The body is not vibrating with its own frequency, but it is vibrating with the frequency of other. And if the frequency of the another source and the frequency of body matches with each other, then it will create resonance. It will create resonance. That means if the body of the if the frequency of the oscillating body and the frequency of the another external force is same, then the body will create resonance. That means the amplitude will get higher, just like this, and this will create a massacre. This can create a massacre, like in our bridge, in our hanging bridge. If the march past happens, then the soldiers are advised to do soldiers are advised to do the march past in a small group. Okay, 2-3 groups are there. So this is the case of resonance. Just like the airplane, if the airplane is going from our house, going through our house, then the aluminum shutter window vibrates. Okay, this is the case of resonance. So these are the oscillations types, types of oscillations: force, free, and damped. I have discussed with this. Nothing you have to remember extra about this topic, just you have to clear this concept, and you have to remember this equation. Okay, so this is the video of the SHM, and I have completed all the parts. Now we will do a numerical session in the later video. If you understood the video and watch if you like the video, then please subscribe our channel and like the video and share the needed person, so that they can use the free lectures, and they can uh, they can I can say that they can use the maximum output of this video. Okay, so please share and like our video and support us. Thank you.